Hello guys, my name is Balkrishna Srivastav and welcome to Code with BK. So in this video, we write a function to delete the node at the given index in the linked list in C program. So before we begin, it is a request to please subscribe to my channel. And if any of my previous videos has helped you out, or if this video helps you out, so please do subscribe to my channel. Alright, so we have to write a function to delete node at the given index in the linked list in C programming. And in this series of videos about linked list in C programming, we saw what a linked list from the very start. The idea of linked list is that we have nodes, node objects linked together using this next pointer. So that from one node you can go to another node. So nodes linked together form a linked list. Okay, we saw in depth the idea and the concepts behind that. And then we looked at the functions, the operations that we can have on linked list. We have a function to get the length of the linked list, get the value at the particular index, print the linked list, print in reverse, insert at end front at a particular index, delete from front, delete from last, and in this case we do delete add. So we are given the head of the linked list and we have to remove the node at this particular index in this linked list. Okay, return the updated head. Okay, and at the end of the video we also see the corresponding delete and get. That is, we remove the node at this particular index and also return the value that has been removed in that node in this remove value pointer. Okay, so suppose if we have a linked list and this is your head of the linked list. Okay, so for this linked list the length is 5. The number of nodes is the length of the linked list. So the valid indices are going to be 0 to less than length. So valid indices are 0, 1, 2, 3, 4. So indexing starts from 0 from the left hand side. Index 0, 1, 2, 3, 4. Okay, head is at index 0, currently containing the value 4. Index 1 has the node with the value 11. Index 2 has the node with the value 13, and so on till index 4. Okay, so if I have to say remove node at index say 3, so I want to get rid of this node, the node with the value 100. Okay, the remaining nodes are the same. We delete 100, so we get 4, 11, 13, and since we deleted 100, the next of 13 instead of being 100 becomes 27. Okay, and then we have null. Okay, so this is head and your updated indices are 0, 1, 2, and 3. The length of this linked list is now 4. This is a problem statement. This is what we are supposed to achieve. Okay, so let's look at the cases that we can have. The first one being list is empty. If the list is empty and you are passed an index in the list to be removed, the node to be removed, you basically return null because there is nothing that we can do. Okay, and this case you can handle according to the description or the requirement that you have been given in the question, right? In our case, we are not throwing any exception, we are not raising any error. Okay, if the requirements say otherwise, that you have to maybe in a way throw an exception, right? Or maybe say print an error, you can code that according to the question requirements. Okay, for list is empty, we return list as it is, that is we return null. Okay, second case, list is not empty. In the case of list is not empty, we take two sub cases. Index is 0, list not empty. Okay, that you have to remove the head node. Third case being index is greater than 0 and list is not empty. Okay, if the index is 0, list is not empty, this is the same as saying remove front. Okay, or delete head. Okay, so you have to delete the head node, remove the front node. We already covered this, okay, in detail. We use the code and idea from that to code this condition. Okay, and then comes this part. So if I code these cases, delete add, okay, if the list is empty, return the empty list. So for index equal to 0, it is equivalent to saying that you have to remove the node from the front, and we know that the list is not empty in this case, so there is at least one node. Okay, so if index is 0, we can simply say return remove, we have delete front, right? Delete front, and we pass head. Okay, using the helper function delete front and returning the value returned by this function. Okay, so by the end of the video, we also see if we don't have these helper functions, how do we go about this? Okay, so if the index is 0, delete the head node and return. Okay, else if the index is greater than 0, right? So we see this case now where index is greater than 0, right? We can also remove the cases that if index is less than 0 or index is greater than equal to len of the linked list, we return head. Okay, in case of invalid indices, do nothing. Okay, so if the list is empty, we return the list as it is, we return an empty list. Else, if the index is invalid, it is less than 0 or greater than equal to length, because valid indices are 0 to less than length. Okay, we return head. Okay, then we come to the case of valid indices if index is 0, and then if index is greater than 0. Okay, so let me just redraw this list here. Okay, 13, 100, 27 and null, and I want to say remove node at index 3. Okay, so index that I want to remove is 3, which is this particular node, the node with the value 100. This is my head. Okay, so I get head, the head node of the linked list, and the value, the index value 3. I will have to remove this node and return the updated head. Okay, so I take two node pointers. I have previous pointing to the first node, I have current pointing to the second node. Okay, so I will say node pointer previous is pointing to head, and node pointer current is pointing to head.next. Okay, these two initializations. Then I will say while current is not equal to null, as long as the current pointer is not null. Okay, and we know the list will have at least two nodes because we are handling the case for index equal to 0 here. Okay, if the list has only one node, the only valid index is 0, which is this case. Any other index in the case of a single node linked list will be invalid. Okay, -1 or 1 or 2 or anything. Okay, so if the control comes to this else part, we can be assured that there are at least two nodes in the linked list. Okay, I take another variable I starting at 1, so I is equal to 1. So I will be pointing to the node pointed by current. Okay, so the index that I stores is the same index where current is going to point to. So my current starts with the second node, which is at index 1, so I starts with 1. I have to remove the node where index equal to I. If this condition is true, I remove the node pointed by current, because I will be pointing the node, I will be storing the index of the node pointed to by current. Okay, all right. If index is not equal to I, the else part is going to be moving the pointers forward. So I say previous equal to current, current is current dot next, okay, and I plus plus. Alright, so when index equal to I, this condition is true, I will have to remove the node at this index, okay, which is pointed to by current. So if we follow this code, current is not equal to null is true, index equal to I right now is false because index is 3, I is 1. Current not equal to null is true, I equal to index is false, so we move forward. We say previous equal to current, so previous points to where current is pointing to, and current points to the next node after current. I becomes 2, I equal to 2 now. Okay, I and current will be pointing to the same node, I will be storing the index, current will be pointing to that node. We go back to check for this condition, current not equal to null is 2, current is pointing to this node with value 13. Okay, if index equal to I, index is 3, I is 2, condition is still false. We skip this if part, we say previous equal to current, previous points to where current is pointing to this node with the value 13, and current is current dot next. Okay, I plus plus I becomes 3. We go back to check for while loop condition, current not equal to null is true, index equal to I in this case is true because index equal to 3, I equal to 2, this is true, and so this you have to remove the node with the value current. Okay, so this loop moves previous and the current pointers forward. If we have a match of index equal to I, that is the node, current node that we have to delete. Okay, so we have to remove current. In order to remove current, you can say I will make the next of this 13 point to 27 instead of 100. So if I say this 13, the next of this 13 points to 27 instead of 100, there is no way I can reach 100 anymore. Okay, there is no reference because I was reaching 100 from head.next.next.next. Next of 13 is now 27. All right. Now you can delete this node with the value 100 and this will be lost. Okay, we will have to free memory because these nodes are dynamically allocated. Okay, so the first thing is disconnect current node from the previous node. So you say previous dot next is current's next. Okay, this is current. Okay, current's next is 27, so previous next is going to be 27. Then you delete this node current, okay, and you return head because there is nothing left for us to do now. All right, okay. And in this case where index is greater than 0, we can argue that head will not change from the first node because we are handling the case for index equal to 0 separately. So in linked list operations, wherever you have this possibility of head being changed, you handle that case separately. In this case, index is 0. That's why our I is starting at 1 in this case. Okay, I starts at 1 because we know that index will not be equal to 0 because we are handling that separately, and head will be at the first node. After this loop, I becomes equal to len of the linked list. Okay, so you simply return then head. Okay, all right. So coding this case, now we have node current starting from head dot next. We have node previous starting from head. I have int I equal to 1. I will iterate as long as my current is not equal to null. Okay, if I find the index equal to I condition, which is the node that I have to delete, I say previous dot next is current dot next. I free current and I return head. Else, if index is not equal to I move my pointers forward. I say current is current dot next and I plus plus. Okay, right, return head. Okay, so this is the case where index is greater than 0 and less than len, and we are handling the case for index equal to 0 separately. All right, so the idea is to reach the node using current and previous pointers. Current should be pointing at the node that which you want to delete. How do you know that your current pointer is at the node that you want to delete? You take this extra variable I that matches for this index that you want to remove. So I and current will be pointing to the same node. I is storing the index of that node in the linked list, and current is pointing to that node. Okay, so the moment index equal to I, you understand that you have to delete this current node. Okay, and the use of this previous pointer is so that we can have previous right behind current. I guess in almost all the references where you have a previous pointer, previous will always be at the node right behind current. So when current starts at the second node, previous is at the first node. When current is at the third node, previous is at the second node, and so on. Okay, in order to delete 100, we will have to set the next of 13 to 27. 100 is pointed to by current, so we need a pointer right before current, which is previous. We set previous dot next to current dot next. Delete this node with the value 100, this ith node, the node at this index I, and we are done. Okay, so let me just test this. Okay, so this is what a linked list is, right? 1327 compile and run. 1327, I will take an index value equal to say 3 for now. I'll say head is equal to delete at this particular index. Okay, and then print the updated list. Okay, so when you remove index 3 in this case, we lose 100 and we have the remaining list. Okay, length is 4 now, so 100 disappeared, it is at index 3. Okay, then if we change the index to 2, we lose the value 13 in this case, so we lose the value 30 in this case. Okay, if the index is 0, we lose the first value. In the case of 0, we lose the first value. Okay, 4 is lost, it is the head. In the case of invalid index, nothing happens. Okay, both the outputs are going to be the same. If the index is equal to the length of the linked list, okay, still the same, nothing happens. Okay, length is not a valid index. Say length plus 100, it will still be no changes. Okay, deleting the last node will be length minus 1, Okay, so compile and run, we lose the last node 27. All right. Okay, so the next thing is we don't want to use helper functions to code this. So we have this helper function length to find the length. So I'm just gonna handle the case for negative index. Okay, so in case of negative indices, okay, do nothing, and we handle the case for greater than equal to length later, separately. I'll tell you how. Okay, so we are handling negative index, we are handling the head of the deleting the head, removing the head of the linked list. So rather than calling this helper function, okay, so I'll say this is, let me just one second not make the changes here itself. Okay, I'll say using helper functions. Okay, and then I copy this. Okay, I'll say without using helper functions, and comment this part as well. Okay, so we wrote this part, okay, that okay uses helper functions to delete the node at the ith index. Okay, right, and now we don't use any helper functions. So we are using this length, we don't want to use helper functions, so I'm just gonna handle the case of negative indices. In case of negative indices, do nothing. Okay, I'll handle the case for greater than equal to length later. I'll just show you how. For index equal to 0, you delete the head. So rather than using this helper function, I'll code the use the code from this helper function. So delete front is basically head equal to head dot next. Oh, okay, so this is the code for delete front. Okay, when you want to delete the head, you save the old head, you move the head to the next node, you deallocate memory, and you return head. Else, if the index is greater than 0, this part remains the same. So this loop handles the case where index can be greater than 0 and less than length. Okay, when the control comes here after this while loop, I is equal to the length. Okay, so for all index values that are greater than length, we don't do anything, we just return head as it is, because this is the part where you have to handle index greater than equal to length. Okay, we do nothing, right? So you don't have to take a separate case for index greater than equal to length in this case, because we are not using helper functions, right? When you come after the, when you're here after this while loop, I is equal to the length, and all cases that are greater than equal to length of the linked list fall here. In this case, we are not doing anything after the while loop and returning the head as it is. Okay, all right, so let me just compile and run this again for the same set of cases. I start, my main is here, I start with index equal to 3. Okay, so compile and run. Okay, index equal to 3 is 100 is lost. Then we have index equal to say 2. Okay, compile and run. Index equal to 2, we lose 13. Then we have index equal to 0. Index equal to 0, we lose 4. Length decreases by 1. We have index equal to length of head minus 1, which is the last node. So we lose 27. For any other index, the list does not change. Okay, list remains the same. For negative indices also, the list remains the same. Okay, all right, so we also saw how to cover this function without using any helper functions. Okay, no helper functions needed. Okay, so I'm going to comment this part because we are a part of this set of functions. I will use my set of helper functions. Okay, this was just for your knowledge. Okay, all right, and I'm commenting this, clear, compile and run. Okay, one last thing is if you want to delete and get at, so basically delete and get, so retrieving the value that you have deleted and also removing the node with that value. So function remains the same, we just update this remove value pointer. Okay, so delete and get at, copying the exact same thing. Okay, so okay, for list is empty, we don't do anything, so remove value will point to whatever value it was pointing to. For invalid indices also, it will not do anything, it will keep pointing to this remove value pointer will keep pointing to the value it was pointing to. In case of index equal to 0, I'll say delete and get. Okay, and I pass this remove value pointer. So whatever the value removed from the head will be updated in this remove value pointer. Okay, then when we are deleting this current, before deleting current we say remove value is current dot x. Remove free current and return it. Okay, all right, so I can also test this delete and get. So head equal to delete and get at index, and I will have to have a remove value, say int removed value is 0, passing the pointer to this percent remove value, and I'll say printf removed value %d \n removed value. Okay, all right, testing this now. Keeping the index equal to 3, we should be losing, compile and run, we should be getting rid of 100. Okay, then if the index is 2, we get rid of 13. Okay, if the index is 0, we get rid of 4. Okay, if the index is len -1, we get rid of the last value is 27. Okay, for any other case, okay, say -1, remove value remains 0. Okay, so you can set remove value to some invalid value which I have defined here. Okay, could be one of those values that you know will not be a part of a linked list, or could be some very high random value. Okay, so in this case my removed value stays to invalid value, which is -1. Okay, all right, so this is your function to delete the node at a particular index in a linked list in C programming. If there is any doubt, there is a part you do not understand, please let me know in the comments. I always try to answer all your comments, and you can also let me know in the comments if there's a question you want to solve, or if there's a concept you want to discuss. So please like this video, subscribe to my channel, and thank you for watching.